Hello everyone, welcome to this video. In this video we are going to solve this question which states that if we are given this group C star under multiplication, right, what is this group C star? It is the group of all complex numbers except the number 0, right? We have eliminated 0 from it. Why? Because the group operation is given to be multiplication here, so you cannot divide by 0, otherwise you would obtain infinity. So here we are given this set H which consists of complex numbers of the kind such that both A and B are members of R, such that A square plus B square is equal to 1. Correct? So here you either have to prove or disprove that H is a subgroup of this group of complex numbers under multiplication except the number 0. So for this, actually, when you are given such kind of situation, prove or disprove, you have to think of some condition which is violated, some example which violates this condition. Correct? If you found one, then you are done. You disprove it. If you are unable to find it, you can try proving it. Right? So here in this case, no such example exists. I have tried multiple times. I cannot find it. So therefore, I say it is a subgroup. I will prove it. Let's check our conditions whether this is true in reality or it is just my hypothesis. So here in this case I am taking two members A plus iota B and C plus iota D from H, and I will check that whether this member into the inverse of this member is also present in H. So if yes, then according to a one-step subgroup test, H would be a subgroup of the group of complex numbers, right? So now because A plus iota B is present in H, what does it mean? It means that A square plus B square is equal to 1. Similarly, if C plus iota D is present in H, what does it mean? It means that C square plus D square is equal to 1. Correct? So we are taking these two conditions and now making use of them in order to find out what is A plus iota B into C plus iota D inverse. So what is this inverse? You can write it like this: 1 divided by this thing, right? And now because we do not want complex number iota in the denominator, so we rationalize it. So we multiply with the C minus iota D in both numerator as well as denominator, multiply the terms, simplify the terms. Now because C square plus D square is equal to 1, so therefore the denominator becomes equal to 1. So we are left with this complex number. Now this complex number would be present in H whenever we have the square of this plus the square of this equal to 1. So let's check what is the square of these two when added together. So the square of AC plus BT is this, the square of BC minus AD is this. So you see, you can cancel out this term and this term, and you can take A common from these two terms, so you're left with C square plus D square. You can take B common from these two terms, so you are left with C square plus D square. Again, you can factorize it to obtain A square plus B square multiplied with C square plus D square. Now both of them are equal to 1 as we have considered both these complex numbers to be present in H, so therefore this is also equal to 1. Now if this is equal to 1, so that means this belongs to H. So that means our complex number A plus iota B multiplied with C plus iota D inverse is present in H. If that is present in H, by the two-step subgroup test, we can clearly say H is a subgroup of C star under the group operation of multiplication. Correct? Okay, now we have another part of this question. It says that describe the elements of H geometrically. So geometrically we are looking for a complex number, right? So this is our complex plane here with this as our imaginary axis, correct? This one is imaginary axis and this one is the real axis. So here you are looking for the element such that the radius is 1. Basically A square, if you are having A plus iota B belonging to C such that A square plus B square is equal to 1. What does it mean? This is nothing but the magnitude. So it implies that the magnitude is equal to 1. So magnitude equal to 1 means we are getting a circle such that its radius is equal to 1. Correct? As simple as that. So this point is 1, this point is what? It is also 1. Correct? this is -1, and this is also -1, and this is 0, correct? So here all the points which lie on this circle, all the points lying on this circle are elements of H. Hence we can conclude the elements of H are the unit circle. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.